cosines, but this time we're given the side angle side. Again, I'm going to write up the law of cosines. On the formula chart, you'll see it just with these letters, but it can be really any of the three you can substitute. You just have to substitute. If you wanted to find B, you would substitute A and B all the way through. This is BC times cosine of A here, and I put the degree symbol because that's what we're going to use in the calculator. So that's how we solve this. So it says, by the way, we could use radians, but the answer would come out in radians if we needed that. Solve for this triangle. Round each side length the nearest tenth, and the angle measures the nearest degree. So my progression of the rules would be this. Is the triangle a right triangle? No. So I can't use psi y cos x, tangent is y over x. Next, you'd ask yourself, do I have a completed set? I don't, so I can't use law of sines. So I have to use law of cosines. So I'm going to try to make a completed set because I think law of sines is the easiest to work with. To do so, I need to find out what A equals. Well, A squared is equal to B squared, which B squared is 12 squared, plus C squared, which is 14 squared, minus 2 times B, which is 12, times C, which is 14, times the cosine of angle A, which is 39.4 degrees. Now that's just straight from the formula. So I can go, to get the answer here, I'll do a square root. And normally in mathematics, anytime you add a square root that's not originally there, you would do plus or minus. However, this has to be a positive angle, so I'm only going to look for the positive of this. So I'm going to go to the calculator, and I'll type in square root. Again, you could end solve all this if you'd like. Square root of 12 squared plus 14 squared minus 2 times 12 times 14 times the cosine of that angle, which was at 39.4. And it was in degrees, so I'll put the degree symbol in here. And let's check it. Yep, looks correct. Press enter, and I get 8.96. 8.96 for my A. 8.96. They said to round each side length to the nearest tenth, which means this will round up just to become 9. So now I have a completed set. And so if I want to use a rounded value, I could use law of sines to find one of the other angles. But I'm just going to stick just one more time so we can see it from the law of cosines perspective. Now that I have side, 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 you could also say that this same value, our answer, we could use the same formula, except I just exchanged the A's and B's. So I could say that, say if I wanted to find angle B, I could say B squared, let me change color so I don't get confused here. B squared, which is 12, equals A squared, which we just said is 9, plus C squared, which is 14 squared, minus 2 times the A times the C times the cosine of B. Now we could use this formula to solve law for B, or again, what we could do, and I'll probably just do it twice here, is I'll show you we could also use law of sines and say that sine of 39.4 degrees over A, which we got as 9, should equal sine of B over 12. And I'll prove to you that we should get pretty close to the same answer. I know there's a rounding difference here. That 9 isn't exact, so we might have an answer that's not quite accurate, but we'll see what we can get. Here, what I would need to do is I would subtract these two. What I would end up typing in my calculator is 12 squared minus 9 squared minus 14 squared divided by, because you'd subtract those first, and then you would divide by this, negative 2 times 9 times 14. That would equal cos of B. And so we would just take the inverse of this. So to get B by itself, B would equal the cos inverse of that fraction, 12 squared minus 9 squared minus 14 squared, all over negative 2 times 9 times 14. We'll type that in the calculator. Let's see what we get. So I'm going to go over here. Cosine inverse of that. It was a big fraction there. It was, let me look at it one more time. Whoops. 12 squared minus 9 squared minus 14 squared. All that over negative 2 times 9 times 14. And we get 58.14. So we're say 58.1 degrees here. Now, if you wanted to use law of sines, you would have had this. Now, remember, we would have cross multiplied and divided. So we would have had that times that. So we would have 12 times sine of 39.4 degrees equals 9 sine of b. And again, what I'm doing is I'm just affirming that this really is 58.1 degrees, showing you could do either technique. And finally, you divide by 9. And after we divide by 9, we would then do the inverse to get b by itself. So we'd find out that b equals sine inverse of this, which is 12 sine 39.4 degrees, all divided by 9. So let's try that in the calculator. So sine inverse of that fraction of 12 times sine 39.4 degrees. All that's divided by 9. I hit enter. I get 57.8 degrees. And again, the difference is just the rounding, because we weren't, here we rounded this, it was 8.96, we rounded it to 9, and really this was kept on going, so that's why these answers aren't exact. But this says round to the nearest degree. So as the nearest degree, the answer should be, according to both, 58 degrees. So either way, it works. So if that's 58, and it's what's confusing is they didn't round this, the nearest degree, it kind of stinks. We're going to say, we'll just use that 58. To find angle C, you take your 180 and you subtract 58. And that gives us 122 degrees. And then you take that 122. So again, what I just subtracted there, that is my angle B. And now we would subtract the 39.4 degrees, which is our angle A. And I don't know why I put the degrees there. The degrees are shown on this side. And so I'm going to make sure I don't mess that up. 122 minus 39.4 is 82.6. And so we're getting 82.6 degrees. That would be our angle C. They said round to the nearest degree, so I'm going to just say 83 degrees. I know it's weird because that doesn't add up to 180, but such is life sometimes. You get weird instructions, you get weird answers. So there it is. All right, so now you try this one.